the second special case involving U substitution is luckily not typically involving inverse trig like the first special case does. This is for specifically when we're working with fractions, really, where I have something like the integral from x of x squared plus 2x all over x minus 1 with respect to x, and I want to find that antiderivative. Well, our first thought would be, well, if u was equal to x minus 1, like we would be used to with using the derivative, well, that means du dx is equal to 1, which means dx is equal to du. But then none of this gets canceled out. I still have x's, so that's not going to work. So we would then say, well, if we tried u is equal to x squared plus 2x, well, then du dx would equal to x plus 2. Dx is 1 over 2x plus 2 du. Well, then this doesn't get canceled out. So that's not going to work. So, and then we're kind of stuck because I'm not seeing an obvious U substitution here. What can give us a clue of what to do next is the degree on top. So the degree of the numerator is bigger than the degree, well, greater than or equal to, of the denominator. If I see this scenario where the degree of the numerator is greater than or equal to the degree of the denominator, most likely what that means we're going to have to do is we need to actually do the long division before we integrate. And so just as a reminder, long division with algebra is done just like long division way back in like 3rd or 4th grade. So the top goes inside. So x squared plus 2x is inside the house. X minus 1 is outside, so that's what we're dividing by. And what I focus on first is the first terms and say, what would I multiply this x by to get x squared? Well, I would need to multiply by an x. So I now take this green x times all of the outside, and I want to subtract that entire thing from the top, from what's inside the house. So the x squareds cancel. 2x minus a negative x is going to be 3x. And I now repeat the process. What I look at the 3x. What would I multiply x by to get 3x? Well, that would be times a positive 3. So now this positive 3 times all of x minus 1. Let's subtract that entire thing. So the 3x's cancel. And then that leaves me with minus a negative 3, which is a positive 3. So now the key here is remembering that the way we write a remainder is I'm adding on a fraction, which will be this remainder of 3 over what I was dividing. So my integral is equivalent to saying I want the integral of x plus 3 over x minus 1 dx, which I can split up to say, well, I want the integral of x plus 3 with respect to x plus the integral of 3 over x minus 1 with respect to x. And I split it up this way because I can just do the antiderivative of x and the antiderivative of 3. And then that means I just need the antiderivative of 3 over x minus 1. And here's where the U substitution comes in, of me saying, well, if U is equal to x minus 1, du dx is equal to 1, so dx equals du. So this would be the integral of 3 over u du, which would be 3 times the natural log of the absolute value of x minus 1. And so what I have then for my entire antiderivative would be 1/2 x squared plus 3x plus 3 times the natural log of the absolute value of x minus 1 plus c. Just as a reminder, I need the absolute value in this antiderivative with natural log because I need to make sure that whatever x minus 1 is, it's positive so that I'm allowed to do the natural log. If I had been given some points or some x values to see if x minus 1 is already positive, I could drop the absolute values. But since I don't know if x minus 1 is positive or negative, I need to make it positive by including the absolute values.